Hello everyone, welcome to our research presentation on material heat absorption and the urban island heat effect. We are Group 4, representing Sri Thamaratsuksa School for the 2026 GLOBE program. To begin, let us have a little background on our study. The urban heat island effect, or UHI, causes city areas to be 2 to 4 degrees Celsius warmer than the surrounding rural areas. This is caused by city geometry, heat emissions, and a lack of vegetation. But then, why this difference in temperatures? It is simple. Cities are warmer because common construction materials like metal, asphalt, and concrete have a high heat retention capacity. Conversely, rural areas tend to have more natural surfaces such as plants, which significantly reduce heat through a process called transpiration. So what were the objectives of our study? Our primary objective was to measure and compare the temperatures of 7 specific surfaces including dry ground, grass, metal, asphalt, concrete, trees, and water. Beginning with our hypothesis, we hypothesized that man-made surfaces like concrete, metal, and asphalt would reach the highest temperatures, while natural surfaces like trees and water would remain the coolest across all 3 periods of measurement, including 11 a.m., 2 p.m., and 3 p.m. Moving on to our materials and methods, we collected our temperature readings with the help of handheld infrared thermometers, held at approximately 1 foot above the surface. And to ensure accurate surface temperature readings across all our target materials, we recorded 3 readings per point of observation. For data analysis, we performed descriptive statistics for all surface types and one-way ANOVA to compare and test the significance of the surface temperature differences. On the screen is a diagrammatic representation of our experimental design. As you can see, it mentions a number of things such as the Globe Land Cover Protocol, which was performed using the Globe Observer application, the ground truthing measurements with infrared thermometers, data analysis with one-way ANOVA, and of course the study area, which is Thailand and specifically Wailak University in the Nakhon Si Thammarat province. So what were our findings? At 11 a.m. and as expected, concrete recorded the highest surface temperature at 50.74 degrees Celsius, while trees recorded the lowest at 26.09 degrees Celsius. At 2 p.m., asphalt recorded the highest surface temperature of 51.05 degrees Celsius, while trees again recorded the coolest of 30.77 degrees Celsius. Lastly, at 3 p.m., metal recorded the highest of 43.1 degrees Celsius, while water was the coolest land cover with 31 degrees Celsius. The trend is very obvious. The anthropogenic surfaces, concrete, asphalt, and metal, consistently recorded the highest temperatures, while the natural surfaces like trees and water recorded the coolest. When tested with ANOVA, the null hypothesis was strongly rejected with a significance value of p nearing 0. This chart captures the story beautifully. It clearly displays the distinction in the surface types by the magnitude of their temperature readings. The bars display the temperature fluctuations across the 7 surface types at different times of the day, including 11 a.m., 2 p.m., 3 p.m. So what are some of the futuristic contributions of our study? The first is the UN Sustainable Development Goals, and particularly SDG 11 for sustainable cities and communities. UHI is used as a key indicator for urban sustainability, and addressing it helps make cities more resilient, safe, and sustainable, particularly through the reduction of adverse environmental impacts in cities. The next is SDG 13, Climate Action, a major focus for taking urgent action to combat climate change and its impacts. Enforcing mitigation strategies, such as increasing green spaces, help in reducing heat-related risk and strengthening resilience to climate-related hazards. Lastly, SDG 7, affordable and clean energy, which also covers smart cities. Tackling UHI is essential for improving energy efficiency in cities as it helps manage the increased energy demand for cooling. Land cover matters. The type of material strongly affects temperature. Artificial surfaces like asphalt and concrete became the hottest, peaking above 50 degrees and acting as heat traps. Nature cools down, natural surfaces like trees, and water remains significantly cooler, around 30 degrees throughout the day due to shading and evaporation. So as a final recommendation, we encourage policymakers to take action to reduce the heat in our cities. We strongly suggest increasing green spaces and planting more trees to act as natural cooling systems. We sincerely give thanks to the facilitators of this exciting study, including Associate Prof. Dr. Krisanade Jaroon Sutasini, Associate Professor Dr. Mulika Jaroon Sutasini, Mr. Tani, Mr. Patsakorn, and Ms. Chada. Thank you everyone. We are Group 4.